Hello everyone. So today we are going to go through another tutorial of generating a histogram. So this code is mainly from professors, and I wrote some comments on it, and also I found some other images to illustrate the idea. So hopefully it will make you feel better about building a histogram. So at first, we have a source image and the destination metrics for visualization, and a hist metrics to store histogram data. So I wouldn't go through too deep or too much in detail of the code, because I think the professor should be uh, demonstrating the code in the lecture. So there are like 2 or 3 points that I want to discuss. So at first, I was very confused with this point plus 0.5 last semester. So I want to show some examples. So for example, if we have 5.2, so 5.2 plus 5.2 plus 0.5 should be equal to 5.7. So if we want to convert 5.7 to an integer, the C++ will truncate it to 5. And for another example, if we have 5.8, so it plus 0.5 is equal to 6.3. And it will be 6 after we convert it to integer. So these 2 lines of code is only to round the index to the nearest integer. And also we should notice that the sum of r plus g is lower than 1. So the sum of r index and g index should be smaller than 256. And this is the reason why we don't care about the right bottom of the histogram, because there should be no value in that area. And instead of printing out the largest bucket, I added another printout here to print out the max value in the normalized histogram using the max value divided by the size of the source image. Yeah, so here is what we just said. We ignore the lower right part of the histogram. And these 3 lines of code is very interesting because we need to care about the weight of the color and also the weight of the histogram. So let me just show you the result of the histogram first. Okay. So the result of the histogram of the arches should be like this. So you can see we have large portion of the red color in it, and we have no value of green or blue color, which is a little bit blue color here, like to align with the image. What if I change this value to 0, which basically we ignore the weight coming from the histogram itself. Let's remake the program and then plot it again. Okay, so you can see the histogram looks very similar to the previous result. What's the reason? I think that is because the max value in the normalized histogram is very small, like only 3%. So the contribution from the normalized histogram is very tiny. So that's the reason why why the value from histogram is contributing small to the visualization. Yeah, you can also play around with this code to verify or get different result and discuss this with me. And yeah, let me just try some other histogram. So if we get a histogram of this picture, what result would we get? Okay, so you can see we get a much more scattered value in our histogram because we have the blue color and green color and the red color in this picture. So how about we try this with all the blue ones? So most of the color is blue. And let's just try one more of green. Okay, so now surprisingly, we get much of the color coming from green. Yeah, so I think this code is pretty straightforward, and I hope this illustration of the results would help you to better understanding the idea. So that's it.